All right, the last section of Chapter 6 is going to be focusing on trapezoids. This whole chapter that we've been working on quadrilaterals, now we're going to finish up with a quadrilateral that does not fit all the properties of our parallelograms that we've been working with. So we want to be able to recognize and apply the properties of a trapezoid. We want to be also able to recognize and apply the properties of an isosceles trapezoid. And once we have figured out what those properties are and how they work with the trapezoid, we are going to determine whether parallelograms are trapezoids. And then I'm also going to add into here that we are going to find the median of a trapezoid. All right, so to get started with this, this whole chapter, like I said, we've been working with quadrilaterals. We have been focusing in over on the right-hand side of everything here, working with parallelograms, rhombus, rectangle, and square, and looking at how all the properties fit with those quadrilaterals. Now we're going to look at a quadrilateral that does not fit all the properties of our parallelogram that we've been working with. And what sets aside a trapezoid from being a parallelogram is mainly its main definition, and that is that a trapezoid is a quadrilateral with only one pair of parallel sides. And so right away that's telling us that this is not a parallelogram. So we have to be very careful about that. It does not fit all of those properties, opposite sides being congruent, opposite angles being congruent. None of those properties are going to work for a trapezoid. What we can work with a trapezoid is knowing that one pair of sides are going to be parallel to each other. And just to kind of give you a little bit more information, when we're working with trapezoid, we have the sides. The two sides that are not parallel to each other are called the legs. And then we also have what are called the base angles. These angles right here, those are the base angles. And also up on top, these are also considered base angles. With a trapezoid, we can be a little bit more specific, and we can talk about an isosceles trapezoid. An isosceles trapezoid is very similar to the definition of an isosceles triangle, with the fact that a isosceles trapezoid has the two legs to it that are congruent to each other. So not only does it have one pair of parallel sides, it also has the two legs are going to be congruent to each other. That makes it an isosceles trapezoid. Now, in this whole chapter, we've been talking about the different properties of all the parallelograms, and so we want to be able to look at what are the properties of a trapezoid. A trapezoid, just a general trapezoid, only has one property, and that is only the fact that it has one pair of parallel sides. That's all we can say about it. There's nothing we can say about the angles other than the fact that when you add the four interior angles, you're going to get 360 degrees. When you add the four exterior angles, you're going to get 360, but that's because this is a quadrilateral. Now, when you look at an isosceles trapezoid, that has a little bit more information to it. And not only does it have one pair of parallel sides, you know, we just talked about how it has the two legs are congruent to each other. And then what else can happen here, and I've mentioned this when we were talking about rectangles, and that is that the diagonals are congruent to each other. Now, diagonals being congruent, one thing that does not happen here is because a trapezoid is not a parallelogram, the diagonals are not congruent to each other. The diagonals do not share a common midpoint either, so we have to be really careful about that. And the other important piece of information here is the fact that the base angles are always congruent to each other. So this angle here and this angle here, those two angles are always going to be congruent to each other. And then we have the base angles up above here, which are also going to be congruent to each other. So now how do we go through and prove that we have a trapezoid? Well, when working with quadrilaterals, one of the best things to kind of work with is just knowing slope, because that's going to prove to you right away if you have a parallelogram or not. And so what we can do here is by using the slope formula as I have right here, This slope formula is showing me that opposite sides are parallel. And the fact that I only have one pair of parallel sides and the other two are not, that means that we have to have a trapezoid. By using the slope formula right away, this would tell you a lot of different things. Because not only would it tell us if we have a trapezoid or a parallelogram, by looking at the slopes right away, you're going to be able to see if you have a 90-degree angles. So then therefore you could look to see if you have any, if you've got a rectangle or if you possibly have a square. So using this formula is really going to rule out a couple things. It's either going to say you have a trapezoid, a parallelogram, a rectangle, or a square. The only thing that it's not necessarily going to say is if it is going to be a square versus a rhombus. So we have to kind of look into that a little bit later. So now that we see, okay, I only have one pair of parallel sides, what if I wanted to figure out, well, is this an isosceles trapezoid? Well, you've got two different ways of doing that. You can either take the diagonals and prove that the diagonals are congruent to each other. So like I have over here on this side, I have AC and BD, showing that both of those diagonals are congruent to each other. So therefore this is an isosceles triangle. Or your other option is to show that um, the the legs itself are congruent to each other. So using the distance formula once again, I can show that AD and BC are congruent to each other, and that makes it also an isosceles trapezoid. So again, one of those first tests that's going to be really helpful for you to look at if you're trying to rule out anything, I would suggest working with the slope formula. It's going to tell you a lot of information, and the slope formula is really not that difficult to quickly calculate. So what we've done so far is we've looked at what the properties of trapezoids and isosceles trapezoids are, and we looked at how we are going to prove them on a coordinate plane. The last and final thing that I added to our objectives for today is the fact of what a median of a trapezoid is. It says a segment that joins the midpoints of the legs of a trapezoid is called the median. What that means is if I have a trapezoid here, I'm going to label it A, B, C, D. If I find the midpoint of AB, because that's one of the legs, so I'm going to say it's right here, and I find the midpoint of CD, and I put a point right there, by drawing a line from these midpoints right here, that right there is our median. Oops. And there is a theorem to go with the median of a trapezoid. And that theorem says that the median of a trapezoid is parallel to the bases. So that means that all three of these lines right here are parallel to each other. And its measure is 1/2 the sum of the measures of the two bases. So right here, my xy, that's my median. So that means that xy is equal to 1/2 of the sum of your two bases. And our two bases are going to be BC plus AD. Adding those two bases together, multiplying it by 1/2, is going to end up giving you your median. So for example, let's say that BC was, we'll go with 20, and AD was going to be 30. Well, if I take 30 plus 20, that gives us 50. And so 1/2 of 50 gives us 25, and that's our measure of xy. Let's say, just to look at another example real quick, let's say you were given the median and you had to find one of the other two bases. Well, we know that the median equals 15. If I add together the other two sides, okay, we have to get 15 once I multiply it by 1/2. So here, you can distribute the 1/2 if you would like, or because I'm multiplying, we can divide both sides by 1/2. 15 divided by 1/2 is going to give us 30 equals x plus 20. And then I'm going to subtract 20 from both sides. And we end up with x is equal to 10. Now again, I know that you can probably figure this out in your head just by looking at the problem, but one thing we want to be able to do here is show how to do this algebraically. And that's the key part, is setting up the formula, using it to prove it algebraically, not just by using the simple arithmetic in your head. So now that we've finished up chapter 6, we have spent a lot of time working with all of these different quadrilaterals and how they work, their different properties. What we're going to be doing now once we come into class is we're going to spend some time, trying to prove what type of shape the quadrilateral is, trying to be as specific as possible. And like I said, that slope formula is going to be one of the big deciding factors of which way we're going to go with here. And I think that's going to be, you're going to find that that's going to be one of the tests that you're going to start with most likely in all the situations. So if you had any problems with anything, make sure you go back, watch the video again, or if you have any questions, jot them down so we can talk about them in class tomorrow.